All right, hello and welcome everybody. I'm just waiting for Instagram over here. Trying to go live on Instagram for my first time. All right, there we go, bang. So, All right, streaming on YouTube, streaming on Facebook, streaming on Instagram. Hey nerds, it's Maddie and we are back at it again. Let me just make sure, YouTube was being kind of weird earlier. So I hope we get some people in here because I couldn't even get like the regular home screen to load for it, so. But I can see my video. All right. Hey nerds, it's Maddie, and we're back at it again today with another Universe Sandbox experiment, and this time we're going to be playing Moonception, or attempting to make moons of moons and moons of moons of moons. So if you're unfamiliar, Inception is the 2010 science fiction film starring Leonardo DiCaprio, where they go into people's dreams and into dreams within dreams. And hold on, I have to mute Universe Sandbox here, otherwise I'm getting the background noise. Mute. Okay. But so if you're unfamiliar, where I got the title from, Inception is a 2010 science fiction film starring Leonardo DiCaprio where they go into dreams and dreams within dreams. So that's where that title came from. If you really want to see a visually stunning masterpiece that's overly confusing for absolutely no reason, it's a must watch. And on last week's live, if you want to go check that out later, we chatted about the United States' return to the moon with the Artemis mission, some of the complications and setbacks that happened, and possible future complications with Artemis 2, such as the fuel leaks that happened, cold weather, and possible issues with the heat shield. And we talked about the seeming lack of excitement around the return to the moon. So you're going to want to go and check that out if you haven't yet. But all right, let's get into the main event here. Moonception. So, can moons of moons exist? The short answer is yes, theoretically. We have never observed it, though, not even close. We haven't even conclusively confirmed an exomoon yet, which is a moon orbiting a planet in another star system, let alone a moon. So everything past regular moons is still physics on paper and simulations in software, but that's why Universe Sandbox is fun. But physics does not forbid it. It just makes it extremely difficult. So let's walk through why it's possible and why it probably doesn't last long. And by the way, exo anything just means of another solar system. So exomoons are moons of other solar systems. Exoplanets are planets of other solar systems. But stars are just called stars because we only have one and it's called the sun. See my Why is the Moon just called the Moon video for more naming fun like this. But so let's get into it. So I think we should be able to at least go 3 levels. I think we should be able to get a moon of a moon. So I just loaded up our regular solar system here. We don't have any of the moons because I think if Jupiter's moons are here, it's going to extremely complicate things. And just to make it a little bit easier, I'm going to actually make it twice as massive. So hopefully that doesn't mess up the rest of our solar system too much and tug everything else out of orbit. Let's just make sure. All right, I think we're still going to be okay. All right, so Jupiter being the largest planet is going to have the largest gravity well. All right, I'll explain that in a second once I get Earth put in here. So Earth is going to be our first moon. We're going to want it relatively far away because the second moon can't get captured by Jupiter's gravity well. And I could have done the math first and made it kind of perfect and easy, but I thought that would be no fun. That's why it's an experiment, so. All right, so let's get Earth in orbit real quick. Okay, so Earth is in orbit. So the gravity well. Every orbit starts with the gravity well. A body must have a deep enough gravity well in order to hold something in orbit. A large mass means a deep well and stronger binding. A planet like Jupiter has a deep enough gravity well to hold dozens of moons, And a large moon like Ganymede actually has a gravity well strong enough that, in principle, it could hold a small submoon or moon. So gravity alone doesn't rule it out. But gravity isn't the only rule. And I'll explain that in a second, but let me get our second moon in here first. And then we're going to talk about the Hill sphere. So if you want to get ahead, you can look up what the Hill sphere is. Okay, so now we're going to add Earth's moon to Earth, which is now a moon of Jupiter. If you notice here, it's actually going to kind of tell us. So this is the Hill sphere, the region where an object's gravity dominates over the body it's orbiting. So a planet has a Hill sphere relative to its star. A moon has a Hill sphere relative to its planet. For a submoon to exist, it must orbit inside the moon's Hill sphere. But here's the catch. Hill spheres shrink dramatically as you go down levels. So you can already see, Jupiter's Hill sphere is really large, but then Earth's Hill sphere is really tiny here, okay? So the Earth's moon has a Hill sphere of only about 60,000 kilometers. Obviously, Earth's is larger, and that'll bring us to the Roche limit. But let me just get the moon in here first. All right, so now we'll slow it down quite a bit. But now we have Earth as a moon of Jupiter, and then the moon as a moon of Earth. And maybe if I'm lucky, I'll be able to get, a small asteroid or something orbiting the moon. But let's see. So now the moon isn't even orbiting Earth anymore. It's orbiting Jupiter. So it was not gravitationally bound enough. So let's bring it in even closer, which is going to really hurt our prospects of getting a third level here. Hold on. I'm going to zoom in a lot closer here. So let's see, right? I guess we'll have to have it pretty close, but hopefully it doesn't get broken apart by the Roche limit. So the Roche limit is the distance inside which tidal forces tear an object apart. So if a submoon gets too close to its parent moon, it becomes rubble. Oh no! Too close. All right, so that was too close. So maybe we'll have to I'm going to make Jupiter like 4 times as massive in order to make this possible. And then maybe we'll have to use Uranus or something as a moon instead of Earth, because that will have a larger gravity well. Let's give it a try. Double click. There we go. All right. So we'll go to Jupiter. We'll make it times 2 times 2, so 4 times more massive. And then let's add Neptune or Uranus. Let's see. I'll do Neptune. So we're going to get it nice and far out and see if Jupiter keeps it. So it's at like 0.7 AU, so it's almost as far as the Earth is from the sun. But it's going to stay gravitationally locked in, it looks like. All right, good stuff. So there's our first moon level. Now let's try to get Earth as a moon of Neptune. All right, let's see if that stays stable. Hey, there we go. Okay. So now Neptune is actually a moon orbiting Jupiter, and Earth is a satellite orbiting Neptune. The question is, can we get the moon in there and get a 4th level? So like I said, if a submoon gets too close to its parent moon, it becomes rubble like we just saw. So now a submoon must live in a narrow band. It has to live outside of the Roche limit, but inside of the Hill sphere. And that band is really small, and we are not done adding constraints yet. So in a planet star system, there are 5 special points where gravitational forces balance, and these are called Lagrange points. You may be familiar with these whenever we launch a satellite or anything like that in orbit. Jupiter famously has Trojan asteroids parked at L4 and L5, but this is where it gets interesting. A moon also has Lagrange points relative to its parent. Objects could temporarily hang out in these regions, but these are delicate balance points. So scientists do believe it's actually possible for our moon to capture its own moon. So while Lagrange points show that gravity allows equilibrium zones, they do not guarantee long-term survival. And Earth is going to be a frozen ice ball. Let's just get a... Look how much darker it is out here now. So this is our Earth that is the moon of a moon. Like I said, so objects could temporarily hang out in these regions, but these are delicate balance points, especially as you get deeper into a hierarchical system. So while Lagrange points show that gravity allows equilibrium zones, they don't guarantee long-term survival. And now we add in the real killers, tidal evolution. So tides transfer energy, and if the moon is tidally locked to its planet, like Earth's moon to its Earth, like Earth's moon to Earth, the angular momentum gets redistributed. So over millions to billions of years, submoons tend to spiral inward or outward. And yes, even our moon is moving away from us at like 3.8 centimeters per year. They will eventually either cross the Roche limit or the Hill sphere boundary, and then it's game over. So tides are slow, but they are relentless. And then we start getting into orbital resonance. So when you stack multiple orbits, you create gravitational harmonics. A planet with a moon with a submoon, a planet with a submoon. Each tiny periodic tugs can pump up eccentricity over time. So essentially they're going to be tugging on each other, right? So that's why I put Earth or Neptune so far away from Jupiter, so that as Earth orbits it, it's not going to get tugged by Jupiter's gravity. But regardless, it is going to get just slightly tugged by it every single time it goes around, and that's going to continue to cause eccentricities in its orbit. I don't think we're going to be able to, but let's see. I think I'll have to place the Earth a little further out from Neptune, but let's just try it here. So we'll see if we can get a 4th level of moon here. All right. Nope. So it's orbiting Neptune now. So you see, so for a split second, it was orbiting Earth, but it's outside of that Hill sphere. So it got sucked into Neptune's gravity and is now a satellite of Neptune, as is Earth. So, bye-bye. Try that one more time. So it needs to be a little closer than that. But like I said, that's probably going to put us past the Roche limit. Let's see. Oh man, it's really close, but it is not crashing. Satellite orbiting Earth. Nice. Earth, satellite orbiting Neptune. Neptune, moon orbiting Jupiter. And then we have Jupiter. So here we have 4 layers of moons. So like I said, physically should be possible. Have we observed it? Not at all. And if it does happen, it's probably more or less temporary and kind of rare. But let's just see if we can get like an asteroid or something. Maybe some really small comet. A random asteroid. Iono. So we'll see if this would be our 5th level now. We have this asteroid orbiting the moon. Nope. Flung out. Where is it going? It's going all the way to Neptune. So the moon tried keeping it, it couldn't. Earth even tried keeping it for a second, it couldn't. And Neptune's far deeper gravity well kept it. Interesting. So, as you add, like I said, so that's orbital resonances. So essentially, as they continue to orbit, each object is going to continue to try to tug the other object out of orbit. So now we get into Kozai Lidov cycles, which, if orbital planes are tilted relative to each other, gravitational interaction can cause oscillations in the eccentricity and inclination as well. So when we're talking about the plane being tilted, we mean it orbiting more like this instead of on the same plane, right? This can slowly drive a submoon into a collision, tidal shredding, or escape. And then we get into the Oblateness. So large planets like Jupiter aren't perfect spheres. Their equatorial bulge alters gravitational fields, and this affects orbital precession rates of moons, and even more so for moons of submoons. Small effects stack up over time. And then you need to think about the angular momentum budget. Wow, Earth is just frozen. You know what? Let's make the sun bigger. I think we can make Earth habitable out here. I don't really care about everything else right now. Make the sun twice as massive. Will that take our moons away, though? Take my moon away. Oop, so Earth is still orbiting Neptune. The moon is still orbiting the Earth. Oh, and Iono came back. Iono came back to Earth. So, as you can see, Earth is close enough to Neptune, and Iono is just kind of being flung about. So now it's back to Neptune. See? It's kind of stuck right at the edge of that, kind of stuck right at the edge of that hill sphere where it's just getting pulled from one to the other, back to the other. So, brings us to the end. Can moons or submoons or submoons of submoons exist? Theoretically, yes. If the parent moon is large enough, or the parent planet, if the moon orbits far enough from its planet, if the planet orbits far from its star, if tidal dissipation is low, if orbital inclinations are modest, and if resonances are avoided. So it's a long checklist, which is likely the reason why we haven't seen any. And remember, we haven't even conclusively detected a moon in another solar system yet. So we're stacking speculation on top of speculation. But the physics itself, it does allow it, at least temporarily. So the honest scientific take, submoons are not forbidden by gravity. They're filtered out by shrinking hill spheres, expanding Roche limits, tidal evolution, resonances, and chaotic three-body dynamics. So it's not that nature says no, it just kind of says, hey, good luck. Are we heating up at all? Not really. Enhance. All right, now the sun is 4 times the mass of the sun. This would be a fun Earth to live on, being a moon of a moon. Let's see, are we warming up at all? Not really. It's crazy. I've made the sun 4 times bigger, but we're just this far out. It hasn't done much yet. All right. Let's make it 8 times the mass of the sun. Oh, that doesn't necessarily increase the surface temperature, I guess. All right, let's double the temperature too. There we go. Now we got a blue sun. Gonna cool down now. Or warm up, I should say. Hey, there we go. Let's see how the inner solar system is doing now. Mercury, never doing good when things like this happen. Venus is getting sucked into the sun's gravity well. Earth is as well. This is gonna go bad down here. Let's take a look. Venus is on this extremely eccentric orbit right now. Probably the same thing's going to happen to Earth. Oh, this is our original Earth, Earth number 1. Mars is coming in to join the party. All the minor planets. Oh, wow. What? I hope it doesn't pull Jupiter in or mess up our moon. Wow. Oh, yeah. Jupiter's getting pulled in, too. I made it too massive. Well, so much for our moon system. See, Neptune's still orbiting Jupiter, even though we're getting pulled in. Earth is still orbiting Neptune. We're getting sucked into this beautiful flower of death. Oh, man. The beautiful flower of death. Let's just see if Jupiter dies or not. We actually kind of... Hold on, let's see if we're still a moon. We're a binary of moon, but I guess we're not orbiting Neptune anymore? Well, where is the moon if we're a binary of it? Oh, wow. It's right next to us and we're white hot. Wow. Times two. Just suck in the solar system. And that's what happens when your gravity well is deep enough to just suck in everything. Even Uranus is coming in for the ride now. And Neptune, there we go. Kamehameha, make, gong gong. And now it's a black hole. All right, thanks everybody for watching. Let me know what you think, if you think it's actually possible to have submoons or even submoons of submoons. I would tend to think that maybe a really massive gas giant, like a really massive gas giant around a really massive star, because then you're really far out from the star's gravity well. You have more space in a solar system like that. Maybe in a system like that, you could actually get like submoons of submoons. So, yeah, let me know what you think. I hope you guys had a